Hello everyone, and today we're going to be looking at implicit differentiation and how to solve some basic implicit differentiation problems. So starting with number 1, so we are asked to determine dy over dx in each of the following. So the first problem we have is x squared plus 4y squared equals 25. So we're going to start off the very first step with doing an implicit differentiation problem, which is right over here. So the first step is going to be to differentiate both sides of the equation. So let's go ahead and do that here. So to do that, we're finding the derivative of this here and then also this. So let's go through that. So what is the derivative of x squared? So we are using the power rule. So hopefully you've learned how to find derivatives by now. I will make a separate video on that in case you haven't, but essentially what you do is you bring the power down, so you get 2x, and if there's a number here, then you would multiply it, and then the power becomes less by 1. So the power was 2, so it would be 2 minus 1, which is 1, so this is technically 2x to the power of 1, but that is implied, so we do not have to write that. So we have that plus, what's the derivative of 4y squared? So same idea, we're going to bring the 2 down. Now we have a number, so we have to multiply the 2 by 4. So 2 times 4 is going to be 8. 8y, because, again, y squared becomes now y2 minus 1, which is 1, which is implied, so you don't have to write that. Now don't forget that with implicit differentiation, anytime you are taking the derivative of a y value, you have to include dy over dx, which basically means in respect to y. That's essentially what you're saying here. Equals the derivative of 25. And the derivative of any constant is always going to be 0. So this is just 0. So we found the derivative of both sides of the equation. Let's take a look at our step 2. Okay, so now you need to collect dy over dx terms on one side and then solve for dy over dx. Well, we only have one term that has dy over dx, so this shouldn't be too difficult, but we need to basically get rid of any term that does not have dy over dx because we are solving for dy over dx. So what I'm going to do is I'm going to move 2x over to the other side because we are trying to isolate dy over dx. And now we're left with 8y dy over dx is equal to negative 2x. Now remember, think of dy over dx as a variable, kind of like an x value essentially. And so what would you do to isolate this variable? How do we get just dy over dx by itself? Well, we would have to do algebra, right? So inverse operations. We have to divide both sides by 8y. So let's go ahead and do that. So we'll divide that on both sides, so this will cancel. And I am left with dy over dx, which is what we are looking for. That's good. Negative 2x over 8y. So we can simplify that. So that will be negative 1/4. So negative, we can just do x. We don't have to write 1 because, again, 1 is usually implied. And then the bottom becomes 4y. That is the most we can simplify. So that will be our answer right here. All right, moving on to the second problem. And I do encourage you to write this problem down in your notebook and write down the steps and follow along with me so that you have something you can reference when you are doing your homework problems or reviewing for a test. So I encourage you to write this problem down as we go through it. So this problem is 12y squared equals 5x cubed. So the steps are the same, right? So the first step is to differentiate both sides. So what is the derivative of 12y squared? Go ahead and try that. Pause the video and then come back to it once you've gotten the derivative. Alright, so hopefully you've tried finding the derivative of both sides of this equation. Let's go ahead and go through it now together. So the derivative of 12y squared is going to be 24y dy over dx. Do not forget the dy over dx, that's very important. Anytime you have a y, you're always going to put dy over dx after the derivative. Equals, and then the derivative of 5x cubed is going to be 15x squared. And now we have very similar to what we had before, where we need to isolate dy over dx, and we can do so by dividing both sides by 24y to get dy over dx by itself. So now these are going to cancel, and I am now left with dy over dx equals, and now we can simplify. Simplify 15x squared over 24y. So we can write this as 5x squared over 8y, because we can divide top and bottom by 3. And that is all we can do. As far as simplifying, that's all we can do. So we can leave our answer just like this. And that is how to do this problem. Alright, so number 3. So we have 6x squared minus 2y cubed equals 11. And the steps are the exact same as the first two problems, the previous two problems. We're going to start off by finding the derivative of both sides of the equation. So again, I encourage that you write this problem in your notebook, try to solve it, pause the video, and then come back to it once you have solved it, and we'll go through it together and see if you got it right. Alright, so now that you've hopefully tried this problem, let's go ahead and go through it together. So first things first is we need to find the derivative. So the derivative of 6x squared is going to be 12x minus derivative of 2y cubed is going to be 6y squared dy over dx equals, and once again, derivative of a constant is always going to be 0. Alright, let's go ahead and simplify this. So we can start off by moving 12x over to the right, because we are trying to isolate dy over dx. So anything that doesn't have a dy over dx, we want to move over to the other side because we don't need it. So those cancel. 6y squared dy over dx. That's equal to negative 12x. And now we can divide both sides by our coefficient, so we can get dy over dx by itself. A lot of this is just algebra. So we'll divide both sides by negative 6y squared, and that's going to cancel it from this side. And we are left with dy over dx equals, so negative 12 divided by negative 6 is going to give us positive 2, because we are dividing top and bottom by 6. So on top we have 2x, and on the bottom we pretty much have 1y squared, but 1 is usually implied, so we don't have to write the 1. We can just say y squared. And that will be our final answer for this problem. Okay, so this is the last problem I want to go over with you guys. I would like you guys to first try it on your own, and then come back to the video and we'll solve it together. Alright, so for this problem, we have something a little bit different. You've probably noticed that when you tried solving it. This does go back to some previous properties when finding derivatives that you would have already learned before learning implicit differentiation. So let's go ahead and go over. So again, same steps. We have to differentiate both sides of the equation. So in this equation, we have 2xy minus y squared equals 4. So the main difference you probably noticed is that we have x and y together in one term. Whereas the other problems, we kept y and x separate. Each term had one variable. So how do we find the derivative of 2xy? Because that's our first step. What I like to do is I like to draw parentheses out when I see this because it helps me visualize the fact that there are two terms combined. So here we go. These are two separate terms that are being multiplied together. So which property or rule, I should say, are we going to apply here when finding the derivative? It's going to be the product rule because these two are being multiplied together, right? We can say this is our f and this is our g, and this is product rule. Now, if you recall, product rule is where you differentiate the first, multiply it by the second, and you don't do anything with the second one, plus the first term multiplied by the second one, but the derivative of the second one. So let's go ahead and use product rule. So we're going to start off with finding the derivative of the first term. So first we have 2x. So the derivative of 2x is just going to be 2. And we're going to multiply that by our second term, which is just y. We're not doing anything with y just yet. We're adding that to the first term, and that's multiplied by the derivative of the second term. And the derivative of y is just going to be dy over dx, because derivative of y is technically 1y, so really it's the derivative is 1. But again, every time you are finding the derivative of a y value, you have to include dy over dx. So you can write it this way. If you want to write a 1 in front of it, you can. Whatever helps you. And then we can do now minus the derivative of y squared is going to be 2y dy over dx equals the derivative of 4, which, as we mentioned in a previous problem, the derivative of a constant is always going to be 0. All right, let's go ahead and simplify this. 2y plus, now remember these are being multiplied, right? So this is going to be 2x dy over dx minus 2y dy over dx equals 0. And now we're going to do exactly what we've done before. Same exact steps. So again, we are trying to isolate dy over dx. And let me just fix that for you. So what we want to do is we want to get rid of any terms that don't have dy over dx because we're trying to isolate it. So this is the term that doesn't have that. So we are going to go ahead and subtract both sides by 2y. And we are left with 2x dy over dx minus 2y dy over dx equals negative 2y. So now we are back to algebra pretty much. So after finding the derivative, it's mostly just algebra. So what can we do to simplify this side of the equation? To isolate dy over dx, because that is our end goal. Well, so we see that each term here on the left has a common factor of 2. So we can go ahead and factor that out. So we get 2x minus 2y, because we can factor the 2 out. And we are left with dy over dx equals negative 2y. And now we can go ahead and divide both sides by 2x minus 2y. The parentheses aren't really necessary, but I feel like it keeps everything a little bit more organized and more structured, so I always recommend parentheses, but you don't have to. And now we can simplify this right here. So we can go ahead and simplify it. Again, 2 is kind of like a common factor on this side now. Equals, on top we have negative y, because we're getting rid of all the 2's. And then on the bottom we have x minus y. And that is our final answer. So this one was a little bit trickier than the other problems that we did before, but these are the type of problems you're most likely going to be doing at some point, and so it's always good to start with some of the basics to kind of get you used to the process and get used to all the steps. Once you get the hang of it, it becomes a lot easier because you're really just following the same steps every single time. You just have to be careful with mostly when you're finding derivative to make sure that you remember that this is product rule. Alright, so I hope you found this video helpful, and if you did, please subscribe to my channel and comment down below any other topics you'd like to see me go over on this channel. And I think my next video, I might do another video on implicit differentiation, but I think I will also make a video on related rates, which is a common topic that is taught pretty much right after implicit differentiation, because to do related rates, you have to know how to do implicit differentiation. So I'm thinking of making a video on that pretty soon. So hope this was helpful. Thank you for watching, and I'll see you in my next one.